Once acquired, most imagery will require some level of data preparation and processing to support imagery analysis and feature identification. This video provides information on data preparation and common imagery processing and enhancement strategies. Our focus for the purposes of this video is image processing and imagery interpretation to support metropolitan growth analysis and urban infill analysis. These two applications form the basis of temporal change studies and offer insight to the planner regarding key trends in residential, commercial, and industrial land development. Data preparation includes importing data from its transmission format, such as CD-ROM or other media, to a working internal format for use by the software package of choice. Most image processing software packages provide data import functions to support conversion of the raw imagery to an internal file format. The internal file format includes numerical and statistical information about the file to support rapid data manipulation. Some internal file formats also support reduced resolution data to support rapid display capabilities. Once an image file is imported into your software analysis system, it may be advisable to subset the image into one or more smaller areas for subsequent processing and analysis. This provides the analyst with the capability to manipulate the precise area of analysis rather than spending time and computer resources on areas extraneous to the analysis. At the other end of the image import spectrum, it may be useful and necessary to mosaic several smaller files into one large file to support analysis over large areas. Mosaicing several large files can often illustrate minor reflectance differences between and among separate images input into the process. Histogram matching provides the capabilities to balance reflectance values between and among individual image tiles. This process provides the capability to modify the histogram of an input image to match that of a reference image. Image geometric correction functions may be required as part of the data preparation process. Key issues associated with image geometric correction through reprojection, datum shift, and registration functions are presented in Imagery Training Video Module 1. The goal of imagery analysis is the discrimination of objects and features into recognizable shapes and patterns to discern meaning. The analyst has many semi-automated and automated tools to assist in the discrimination process. Imagery enhancement spans a range of processes and functions, ranging from simple grayscale enhancement to complex multiple image resolution merge functions. Enhancements are performed on imagery to support manual, semi-automated, and automated analysis. A simplistic form of image enhancement consists of manipulating and choosing the band or bands displayed as part of the analysis. This band selection allows the analyst to accentuate specific wavelength regions, some of which may correspond to features of interest in the analysis. A second set of image enhancement functions consists of spectral and textural enhancement, providing the capabilities to manipulate the digital values of the input image. Grayscale and contrast enhancements are used to sharpen distinctions between objects and their background. This form of enhancement is available in both low-cost picture processing software and in professional imagery processing software. Image enhancement also includes functions that match the brightness histograms between two or more images. Such enhancement is often necessary to standardize the overall image brightness and contrast between and among images. A third type of image enhancements include a set of image transformation functions. Image transformations create new image data from the original image input files. These transformed images often reduce the dimensionality of multiband imagery into one or two most significant bands, based on the statistical properties of the input image. The most straightforward of these transforms is the band ratio, whereby the pixels of one band of the image are divided by the corresponding pixel values of a second band of the image. A second image transformation is the tasseled cap transformation. The tasseled cap transformation was originally developed to assist in the understanding of important agricultural crop phenomena. As shown in this example, the tasseled cap transform can be used to differentiate urban, non-vegetated areas from non-urban areas that have greater amounts of vegetated surface area. The final transformation that we will discuss in this video is the principal components analysis transformation. The principal components analysis transformation creates a new image in which the new bands minimize the intra-band correlation that exists in the original input image. The image enhancement and image transformation functions that were discussed previously can be used to support temporal analysis using multi-date image sources. Given at least two input images with different acquisition dates, the change detection process starts with manual imagery analysis using image display, overlay, and image blend functions. A change image can be created using semi-automated image processing functions. The change image is a single image derived from two input images with different acquisition dates. The change image has unique characteristics that identify the locations of change and which signify land use and land cover change between the two input image dates. Image change analysis can support urban area growth analysis over time. In this example, we show multiple images taken at different dates over Manassas, Virginia, approximately 25 miles west of Washington, D.C. This image shows declassified panchromatic corona satellite imagery from the early 1960s, overlaid on color infrared photography of the same area taken in 1995. Note the overall lack of development in the area depicted in the corona image. The next image shows the same area in 1989 using U.S. Geological Survey digital orthoquad imagery. Note the residential development and the initial commercial development around the intersection of Interstate 66 and Route 234. This 1995 imagery, courtesy of image vendor Vargis, shows the area underwent additional commercial development, including the development of a large parcel that contains a big box retail store. The final image in the sequence shows year 2000 Akanos imagery from Space Imaging. This image shows continued commercial development of the area, including a large shopping complex that has spread commercial development to the opposite side of Interstate 66. Image change analysis was performed using low-resolution Landsat 5 imagery that was acquired in 1991 and 1997. Image change techniques were used to derive a change image where green areas indicate areas of land use and land cover change between 1991 and 1997. In this image, we can identify the road widening along a portion of Interstate 66 performed during the period, the development of a cross-county parkway, and large patches within an agricultural land use area that indicates agricultural cover crop change. One particular area of interest in the change image is located directly southwest of the intersection of I-66 and Route 234. Tax parcel data of the area shows that the building value of the parcel identified in the low-resolution image change increased in value between approximately $5 and $9 million between 1991 and 1997. High-resolution imagery of the area shows the parcel as undeveloped using 1989 imagery. High-resolution imagery acquired in 1995 and the year 2000 shows the parcel was converted to a regional retail shopping complex. Thus, low-resolution imagery has been shown to be a useful tool to identify the locations of change areas, though high-resolution imagery is often required to identify the nature of the change. These examples show the use of imagery to support residential infill analysis. Low-resolution imagery acquired in 1993 and 1999 was obtained to support change analysis of a portion of Riverside County, approximately 60 miles east of Los Angeles. In this 1993 image, brown areas depict forest lands, white areas are cleared vacant areas, red areas are golf courses and other vegetated surfaces, and blue-pink areas depict residential land use. Analysis of 1999 imagery of the same area provides the analyst with evidence of expansion of the residential area into areas that were previously cleared and forested. Additionally, new vacant and cleared areas can be identified as being carved out of areas previously identified as forested. High-resolution imagery of San Diego County, California, further illustrates the use of multi-date imagery to support residential infill analysis. This image illustrates 3-foot resolution color DOQ imagery from the USGS acquired in 1995 surrounding the region of Del Mar in northern San Diego County. This is 1-meter resolution year 2000 IKONOS imagery from Space Imaging. Comparison of this imagery with the 1996 DOQ provides the analyst with precise locations of change, as well as information on the nature of changes. Imagery change analysis provides the capability to determine land use trends over time. These changes can be identified, measured, and categorized to support trend analysis. Statistics that are derived from the imagery analysis can be used to develop charts and tables and incorporated to support documentation and reporting. Imagery of the changes can be referenced in the text and the tables to provide maximum visualization by decision makers and the public.